Yeah, I've been working on a project recently and I wanted to show a demo for it. So, what I was trying to do was, get the latest research papers in the field of machine learning and try to find an underlying theme as to what's the major part of research these days. So I wanted, not to go inside the papers to check the content, but just based on the titles of the paper, just get a lot of papers and see what's getting published in this month and in the previous month, and just to find what the researchers are working on. So I found this website. It's maintained by Cornell University, where researchers can publish papers. So they expose an API, so you can get all this information. So this is for the current month. This is 120 entries, but like for the previous months, there were about 800 entries. Actually, not for the I mean, there were more than 800 entries. So I used this website. I got all these papers from here. I mean, I got the titles from here, and then I wrote a Python program, and I used LangGraph, which is an AI framework which is quite popular these days. And after getting the papers, I wanted to cluster them. So I tried three different clustering algorithms. Then I used LLM, just like ChatGPT, to for certain tasks, such as um, I wanted to extract like the relevant phrases out of titles, just so that I could cluster the papers on a deeper level. Like if I had phrases, I could match phrases together and find clusters based on that. And OpenAI embedding generation. So this is so the way AI understands our questions is because assigns an it assigns a mathematical representation to each text. And to for the clustering algorithms to work well, we need some meaning attached to our text, like each word. So I use the open AI embedding for that. I'll show that in the demo. Then I used Python programming to write my code, Python along with LangGraph. And then again I did a final theme extraction from all the clusters. Let me just start with the demo. So the first thing was that I wanted to map each title to its relevant phrases. So for example, like this is the paper title. So I asked AI to find the relevant phrases from it. So it found relational priming, transformer, multivariate time series. Second one, again, it found this. Then it's a geometric approach to learning composable representations. Um, this one, it found auto encoders. This is generative adversarial network. GN stands for that. So it's cycle generative adversarial network, and then adversarial learning. This one, it found neural networks, neuron pursuit. So this is how I did this for all the papers. So I have I have a lot of papers. I think around 700. So this was the first step. The next thing was that I created embeddings for all of these. So each word, so the what AI can do for us now is, instead of earlier without AI, these were just texts, but now with the help of AI we can give it a meaning. So relational priming itself has a meaning, transformer itself has a meaning, and like multivariate time series has a meaning. S- Um, so so instead of networks just having a meaning, networks will have a certain meaning, but neural networks will have a different meaning. Um, so learning could have a simpler meaning, like learning is anything that you learn, but machine learning can have a particular meaning. So AI is able to provide context to text, and the way it does is it creates embeddings for each of these texts that we provide to it. So the next thing was converting these into embeddings. So this is what an embedding looks like. So each phrase is mapped to a set of mathematical numbers, and it's a huge number actually. So like this, I mean, you'll find like this is done for all the words, and there are 17,000 phrases that were found. So I assigned embedding for each of these. Now after assigning the embeddings, now every phrase has an embedding. Now the next step is to pass these embeddings to a clustering algorithm. So I used three clustering algorithms. One was, so all the three were called KMEANS, HDBSCAN, and agglomerative. So initially I started with KMeans, but I found a limitation of this. The limitation is that before you can cluster using K-means, you will have to provide a cluster number to it. So if you provide 5, it will take all of the things you want to cluster and divide it into 5 clusters. If you provide the value as 10, it will divide those into 10 clusters. Now this is not good for our research paper project, because research papers could have 100 different underlying themes, right? So we want the cluster number to be dynamic based on based on the actual clustering. Like if we just say 5 or 10 or 100, even though something will not fit in the cluster, this algorithm will fit something into it. So that is why I rejected this. The other two are HDBSCAN and agglomerative. These do a decent job of clustering, and I found this one, agglomerative, to be the best out of 3. HDBSCAN also has a limitation that one, I found that it couldn't cluster, like the agglomerative had better clustering, so I found that two different concepts could be in different clusters, but it got merged in HDBSCAN. And the other was that it also could not find a lot of things to fit into a cluster, so it creates a noise cluster, which is basically empty, like single theme. So if for a paper title it doesn't find a particular cluster to fit it in, it will put it in noise. And then I saw that noise cluster was very large, and some of the things in the noise cluster could have easily fit into some cluster. So even though it did a decent job of clustering, I did find some drawbacks to it. This agglomerative was the best out of the 3. It is still not perfect, but considering everything, it gave a decent clustering. And I use LLM prompting, to extract phrases, which I've already mentioned, and the embedding I mentioned. Okay, so let me show you the cluster summaries again. For K, let me show you K-means first. Now I gave 10 as the value, so it fit everything in like 10 clusters. So it fit all of these words in 10 clusters. So I mean, if you really look at it, AI could have its own cluster, then compressing could have had its own cluster, diffusion could have had its own cluster, but it fit everything into these 10, so that is why I rejected it. The next was HDBSCAN and agglomerative. So HDBSCAN actually found 318 clusters, and then it found a cluster noise. So these were basically which didn't fit in any cluster, but I'm sure we have a learning cluster in that, so these two could have fit there. And there were other things also I found. So I mean, it's a huge thing. So this fit 300. This found 318 clusters, and then a cluster noise, and then agglomerative one. So this found about 422 clusters. So now I'll show you a side-by-side comparison of both of them. So I made a summary. Okay. So Okay, yeah. So this is the side-by-side comparison. As you can see, this is on the left is HDBSCAN, and it created one cluster where there were phrases related to multimodal, and then it also found phrases related to fusion. Whereas if you see on the right side, this is agglomerative. It created a unique cluster for multimodal. So this differentiation is also already better than the left side. And then it also created a cluster for fusion. Well, okay, this one is diffusion. This one is fusion. So it created another cluster for fusion. So it created two separate clusters, so which is good. It's better. So I found this better than the HDBSCAN. And after running the clustering, I found the top 100 themes. So I'm going to show both of these. So this was for agglomerative. Let me do that. And this was for HDBSCAN. So these were the themes eventually that I found from both of these clustering mechanisms. Now to find the themes also I used two different methods. Uh, so method one was I passed the clusters to an AI. So I passed a list of phrases that were clustered together. I gave it to AI, and using a prompt which I can show. So I use this prompt that analyze the following paper titles, which is phrases, and extract one strict common theme, either one or two words only between all titles is phrases here that you have the highest confidence in. Optionally, if there is a second strict common theme that you identify, extract that also. And ideally, the theme should contain words or closely related to words that are commonly present across titles. And then I asked it to normalize them to their singular form, which I will talk about a bit later. And if there is more than one phrase, include themes that are clearly relevant to all the phrases titles. And I asked it to return strictly as a valid Python list, and do not include any code block formatting. So return it in a way that my program can easily take the response and do further, you know, coding on it. So this was the prompt I passed to the AI. I used OpenAI. Actually, I used OpenAI before. Then I used Anthropic, which is another, company. And then it returned as as I had shown. So basically, it returned this. So it returned each cluster with these themes. So it found these themes based on these things. So like it says hallucination, so it returned the theme hallucination. And like if you go on the top, it found this cluster. So most of this is optimization. This one is multimodal. This one is graph. So it returned a theme graph, and it returned another theme called structure. So based on these themes, then I, calculated how many times these themes are occurring, and how many words were there. And so like optimization could be twice, because it's a single word theme, right? So optimization is found in the first one, and then also these things, policy optimization, gradients is optimization in machine learning. So it could be found multiple times. So this is distributed optimization. So as you can see, there are two themes. Even though this is optimization, this is distributed optimization. And so these must be the methods. Like some of these things I can't understand because or my limited English, but machine can understand it. That's why AI is so powerful. Like it can understand better than humans right now. At least in text processing, maybe not in actual idea creation or things like that. But when it comes to text, it's pretty advanced. And this is like another kind of optimization. Like the common theme was optimization, so it must be different types of optimization. So policy optimization curves, like so then I made like I took different, like this has 18 phrases and this has 7 phrases, so I kept adding it. So eventually I found, after calculating all, so we'll see that. So here optimization from agglomerative clustering gave us optimization 40, and here in the HDBSCAN it came 34. So these are in the top 10. So the themes I found from like the top 10 are like from here. If you see common is learning, and then this has network, this has neural network, um, this has graph, this has a graph as well, this has network, this has network as well. So if you can see, let's see network. So it yeah, so ensemble networks is probably, so these all probably relate to network. So this is ensemble network, this is network. So ensemble learning, let's see how it is. So how ensemble learning relates to networks. So neural networks as base learners in ensemble often combine multiple neural networks. So even so this is the like the power of AI. Even though I can't understand this because I'm not from machine learning, I'm not from a machine learning background, the machine understands it because it has been trained on phrases from around the globe, like from the internet, from documents on the internet. So it understands it. I can't understand like what these things mean. So but it can understand it. So like zero shot. Now zero shot versus few shot. Let's check this. This is another example. So it says zero shot learning and few shot learning. So even though these two words don't have learning within it, they found a common theme called learning because the LLM has been trained on words, on machine learning papers maybe, and it knows that these things are used in machine learning, and it's a particular type of learning. As you can see, it's called few shot learning, zero shot learning. So machine can find things which like we can't find. Like it can find underlying themes. uh, so this was one of the ways I used LLMs to predict the underlying themes from clusters. The other method I used was without the LLM. Like if LLMs didn't exist, how would you do it? How would you find common themes out of clusters? Well, the only way to do it would be to find the common phrases in each of the clusters and take that. So I did that also. So in this I found so this was another way. I found the most used words in the most used word in the cluster and took that as the theme. So this has optimization as the common word, this has multimodal as the common word, this has graph as the common word. Let's go a bit down. Let's see quantum. So this has quantum. Actually, let's compare here. Cluster 19. Okay. Okay, so with LLM, these are the same clusters, right? This one, and these are the same clustering algorithm also, agglomerative. But one In one, on the left side, I asked the AI LLM to find themes, so it found architecture and device. Because microcontroller is a device, again hardware related is a device. This is device, and maybe, you know, because these came out of a paper, so the embedding, initially the context was put under device. Um, and this one is because it's just a common, this is the other way, this is common, architecture is the common word, the most common you could say. Okay, so there's, so it took the first one because there's no common, okay, architecture is there, otherwise all words are different. Yeah, let's see, 211 ensemble network. So if you see the next cluster, it took ensemble and network as the themes. The AI found two themes, whereas just if you just search the theme according to like the most used phrase, it's ensemble. So this is the difference between the two methods. I would say that I mean AI can give, both the methods are good. Both can give you a good idea, but AI obviously is more powerful and it can give you themes which you can't see, like from as a human being, like AI can understand things better. So I would say that both, use both. So these were the charts, and I found these. So these are only the top 100, but there are a lot of other, you know, themes which were found. But like, just to know what the latest research is going on, we can just see the, you know, the top 10, top 15. So currently it's still learning. Reinforcement learning is a big part. So I also like map titles to each of these. So initially I had like this paper list. Uh, so this was my paper list. This is the titles of all the papers, and then I eventually mapped um, the themes generated to the papers which contain those phrases. So just to go back again. So from every paper title, I extracted phrases, right? And then out of these phrases, I created clusters. So eventually, the topmost clusters. So actually, after clusters, I found themes. Then I merged the themes together, and themes could have, like, if like, so themes got mapped to these phrases, and then phrases are mapped to these titles. So I mapped themes to titles, like in the end. That's the last step. So if you want, so let's see, from LLM. So like, if you see, finally, like, these are the learning under the learning themes. Actually, let me open this in. So from the learning theme, these are the papers that got mapped under it. Most of these have a learning word in them, and some don't have, but those would probably, the AI thought that they could fit here. So I want to find a easier one. So like this one, right? This one. Now I can understand this, even though it doesn't have the learning in it. RLHF is actually a learning method. So because I've been doing this project, I've come across some terms. So RLHF is reinforcement learning from human feedback. So even though at first glance, like for a non-researcher or somebody who's not in machine learning field, they would look at this and say, you know, why is this paper in this learning theme? But like, the AI has been, you know, trained on documents around the world, right? Like on the internet. So it understands that RLHF is related to reinforcement learning, which is learning. So similarly with other things, it might have found some underlying things which I can't understand. but it found all these papers, these are based on learning. Now, the clustering algorithms could be better with, maybe there are better clustering algorithms out there. Maybe tuning of these algorithms would result in better, clustering. So that could always be improved upon. But finally, like these are my observations. Like KMEANS has a limitation that you have to give the cluster beforehand, so that doesn't really solve our purpose. Because KMEANS I gave 10 clusters, so it put everything in 10 clusters. HDBSCAN created around 318 clusters, and AGGLOMERATIVE created 424 clusters. So the clustering algorithm has to be dynamic. LangGraph I used. So LangGraph I just want to show you the node state that I had. So LangGraph I ran two types. I didn't talk about this title one because I couldn't see good results. So the two things I tried. One is in the demo I showed that I extracted phrases, relevant important phrases from title. So I broke every title down into phrases, and then I found clustering on those phrases. I also tried another method where I just gave directly the title to AI and I asked it to cluster it. Actually, I gave the title, I created embeddings from the title and I gave it to clustering algorithms to form clusters, but I couldn't understand like if they were right or wrong, maybe due to my limited knowledge. I can show you based on titles also I created some clusters. So let's see agglomerative. So for titles I created 125 clusters. Let's see cluster 116. Let's try to understand. There's a cost sensitive framework for accelerometer fault detection, real world streaming. This is I don't see any similarity in this. Classification of 24-hour movement behaviors from accelerometer data. So okay, so accelerometer here. Ensemble distributed distillation for self-supervised human activity recognition. All I can say is this is something related to real world, like fault detection in real world, self-supervised human activity. This is also real world. Classification of 24-hour movements based on wrist-worn accelerometer data. This is also real world. I mean humans. And multimodal sense and fusion is again something real. It is measuring something in the real world. So maybe this cluster is that. Maybe let's check another cluster. Let's check 51. So this one is dynamically adapting reinforcement system, reinforcement, adaptive temporal fusion transformers. Okay, the other one is reinforcement. So okay, it is doing a decent job actually. But I think I saw some bigger clusters and I was like, this I don't know if it is right or wrong. Let's see cluster 0. Okay, so I must have seen this and I would have thought, okay, it's better to. I mean, eventually I want to know if it's right or wrong, if the clustering algorithm and project I'm doing is giving the right results. So maybe I went with the other phrase, breaking these into phrases because it's easier to understand for me. But the previous two clusters based on title were decent, I would say. But another thing is that like this, the clustering has to, now if you want to find themes out of this has to be done by AI. AI also has a limitation of processing time and cost related to it. So I mean, so I tried. Let's just I tried two methods, one from title directly and one from phrases, and these are all the three clustering algorithms I ran in parallel. One first for title and then for phrases, and eventually I got the results and I wrote them to file. So this was my node graph, and other results were I found some limitation with parallel branches, but as I learned more I would say like not everything needs to become a node in LangGraph. Some can be utility functions, but I think it could be improved in some places. Prompting, yeah. So one thing I would like to say is that initially when I was asking LLM to create themes, it created two different, like somewhere I found that it created theme called neural network, and some place it called neural networks. Now my program was combining all of these themes together to print the final chart, right, as to what's the dominant theme. So it created, so it clustered, so it made these as two separate bar charts, even though they are same. Like I can tell as a human that neural network and neural networks could be or should be combined together, but like Python program doesn't understand context, even though it returned these. But my after when I was clustering, my Python program doesn't understand context. Either I understand context as a human, or the AI understands context. So eventually I asked, before returning themes, that whatever theme you find, normalize them to their singular form. So eventually it gave neural network, and where it was giving neural networks, it gave neural network. And then I combined the papers from both into a single set. So because all the papers now relate to neural network, I didn't have two different sets. So I can easily combine papers and see, okay, what from both these research themes, because they are the same. So prompting is also kind of an art. So small things matter. So but we have to write everything in the prompt. So I want to show you some prompts also now that we are on it. So this was the prompt for theme, where I asked it to normalize to a single form. So I asked it to analyze paper title and extract one phrases, and extract one strict common themes among all. So this was for the theme. But I did also have some other prompts. One prompt I used where I wanted to extract phrases from the paper title, so I used another prompt for it. So I initially, when I want, this is the very first step. So when I had all the paper titles, I wanted to extract phrases. So I asked it extract the significant phrases that represent this from the research paper title. Keep only the stronger individual phrases and discard the less important repeatable ones. And eventually it gave me the output, which was this. Every title, the most relevant phrases. So I used a prompt for this also. And okay, the other mention was on the same thing related to phrase extraction. Eventually I went with AI to extract phrases from this, but because AI has a cost related to it, so I was finding free versions also, if I could extract relevant phrases from text. So I did try these three different there are three libraries, Python libraries and softwares which you can use. Just a sec. Yeah, so I tried these three. One is called KeyBert, one is called Spacey, and one is called Yake. These don't use AI LLM. These can be run on local computer. So I will show you the results of both three. So Spacey had these results. So like deep reinforcement learning, utility tuning, and the ad recommender system, like from the first one. KeyBert had like tuning, ad recommender, Pinterest, deep reinforcement learning, ranking utility, and utility tuning, ad, and Pinterest. And the third one was Yake. Yake also gave like Pinterest, reinforcement learning. So I think eventually I had more confidence on the AI to do the job. So I went with AI because AI could understand the whole context. These three, the other three which I showed, these can't understand context. I don't know how they work internally, but I think AI is very powerful in understanding the whole context and finding the relevant keywords. So I had more confidence, so I went with it. So this was one other thing. Yeah, this was it. Just in the end, one more thing I can show is if there was no AI, as I mentioned, you would find the most common occurrence of words in the clusters, right? So that is how you would see what the theme was in a cluster. And I also ran just another program just to take all the titles, break every title into each individual word, like every single word out of all the titles, and I made a combination of it. And yeah, and I found that across all the 700 people titles that I analyzed, learning was the most common used word, and this also sits well with our clustering algorithms. The second most found theme was learning, and in HDBSCAN it was the first most found theme. Models, I think model is there in HDBSCAN. Okay, it's somewhere down. Maybe data was another theme at the top. Data was the most commonly found word, and data in agglomerative, like the theme data, came at 43, and in HDBSCAN data set is at 8, and data is at 8. So yeah, so this was there. Yeah, this was it. Thanks.